So you want to buy a suppressor and you want to know which one is best. You'd think it would be a pretty straightforward process. Well, it's kinda not. Most people focus on decibel readings to judge whether a suppressor is superior to others or not. And the one company that has figured out a way to measure through a scientifically standardized process has been our good friends at Pew Science. But that's just decibels. Decibel readings are one of the most important variables to take into consideration, and Pew Science is amazing at doing what they do, which is why we are not going to be focusing on decibels per se for this review/video. We will be analyzing the new SIG SLH and comparing them to their predecessors. According to their website, these new suppressors feature a new clutch lock QD mounting system in an internal multi-flow path with a focus on sound reduction, while also reducing up to 50% of the toxic fumes venting through the ejection port. Now, according to the patent, we were able to study a diagonal cut diagram of it that calls it a suppressor with integral flash hider and reduced gas backflow. Now, is this a new concept? No. A little further research in other patents referenced by the one filed by SIG reveals that there are at least 2 prior designs that feature relatively the same design as the SIG one. Just to touch up on a couple of them, we have the WHG Properties from Pennsylvania, and the second one from UT Battelle, which seems to be a project that I suspect was intended to be research for the Department of Energy based on the Oak Ridge and Livermore locations. After a little Googling, I confirmed that that was the case. I had the opportunity to work for the DOE and the NNSA, so I'm leaning to believe that the only reason why they would ever look into designing a suppressor was probably to outfit their tactical units with them, maybe, but who knows. Let's go back to SIG. These new SIG suppressors are 3D printed. This means that they can design much more intricate internal flow paths compared to the conventional suppressor manufacturing methods. So in this video, we will cover things such as that, and also the material that suppressors tend to be made of, heat dispersion, heat retention, weight, length, IR signature, and gas mitigation, and how all that plays part in which suppressor you should pick for your own particular environment. Now, this is gonna be a long one, so get yourself some snacks. I'll wait for you here.
Ma, do we still have Doritos?
Suppressor is 49.8 degrees. First round's through. 9-inch MCX with the SLH C compact 7.62 can. Almost no gas at the shooter. A little bit coming out the ejection port, but most of that gas getting pushed downrange. That's a compact can though. Temperature reading after 4 shots, 85 degrees. Can temperature is 48.7 degrees. Listen for first round pop on the Rattler. Here it is. Sorry, didn't change my gas block. So first round pop to second round shot. It's gonna be hard to discern. Much quieter. Lots of gas at the shooter, lots of gas coming out the ejection port. Second temperature reading after 4 shots, 77 degrees. TI direct thread, titanium can. Barrel suppressor temperature is 50 degrees even. Very little first round pop, lots of gas at the shooter, wind change direction. The gas is hovering. Can temperature is 65 degrees. Tac Ops barrel. Suppressor temperature is 48.7 degrees. Lots of gas at the shooter, very little change between first round pop and second shot. Final suppressor temperature. Not a huge delta. 60 in temperature. Curtis with the SLH 762 suppressor. Suppressor temperature is at 51 degrees. Super loud first round pop, followed by a somewhat quieter second shot. Not a ton of gas at the shooter, not a ton of gas coming out of the ejection port. That first round pop was loud. 20 round degrees hotter than the TI can at the
After
muzzle.
shooting 4 rounds, 86 degrees. Rattler mag dump. Suppressor temperature 63.3 degrees.
Tons of gas at the shooter. Can no longer see my target. Lots of gas within 6 feet of the muzzle. Gas still coming out the ejection port. But super fucking quiet. Super significantly quiet over the 9-inch.
After 30 rounds, suppressor temperature is 258 degrees at the hottest point in that instance.
258 degrees at the hottest point after a mag dump, which means that it's a steel can, it's not a titanium can, so it gets hot quick, which is good. It's pulling energy out of the system in the form of heat. Why the Rattler is so quiet in this, the 5.5 inch barreled system with the SRD QD steel 30 cal can.
Suppressor temperature is at 61.8 degrees. This is a 26 round full auto dump through the MCX.
Had a failure to feed, short stroke, dirty gun. Lots of gas at the shooter, lots of gas coming out the ejection port. Plume of gas is now about 8 feet downrange past the shooter with the back wind, a little bit of wind to the back. Very hard to see past that cloud up close.
You want to get a close up in there of how wet it is? And
That's from combustion.
it's a dirty girl as well.
Lots of wetness, lots of carbon buildup.
Combustion.
It's disgusting in
water.
there. Filthy gun.
182 degrees. So it's enough to cause tissue deterioration over time. But it's cool enough to touch.
182 degrees at the center core of the suppressor on the machine gun MCX 6.75. That's the LVAW style build. It's a titanium can. It's a longer can, more baffles, more fins. And because it's titanium, it takes longer to get hot, but it means that it takes longer to cool down. 180 degrees is still not that hot, but the titanium cans don't pull a ton of heat out of the system. The nice thing about the titanium cans is when you are in fact running them hard, even not hard, even if you're just, you know, doing failure drills over the course of a magazine, that means the can is not that hot. That means the can is not going to burn your leg or some part of your body if you accidentally touch the can. So that's something notable. You're not doing mag dump after mag dump through these guns in the real world. So having the can be that temperature after a 30 round mag dump is quite significant, and it's quiet.
9-inch MCX Virtus with the SLH full-size can. Can temperature 66 degrees. This will be full mag dump.
You can already see gas much faster exhausting out the muzzle downrange. There's still a significant amount of gas at the shooter, but a lot of gas downrange. Still a lot of gas coming out the ejection port. 291 degrees. All right, so after a mag dump, in a 9-inch gun, which you would expect all the powder to be burning, or most of the powder to be burning in the barrel, you're getting a very hot can. Inconel is great against holding up to high temperature, but it does get hot very quickly, which is not a bad thing. In terms of sound suppression, converting all that energy into heat inside the can does make it quieter than it would be if it didn't have the system that does for a surge can. Only problem is 291 degrees is a heat signature. Night vision or thermal, this thing is now glowing the operator from distance, versus the titanium can at 180 degrees throws a much lower heat signature. Just, you know, something operational to keep in mind, not necessarily, you know, like for your everyday shooter, but you know, when you're choosing a can As a military unit, you know, it's great having the gas being pushed away from the operator, protecting the operator, but at the end of the day, it also has a lot of heat going into that can. A can is now hot enough to burn someone if it touches raw flesh. So, you know, maybe a suppressor cover would be useful in this, but that can gets really hot. Aaron Cowden from Sage Dynamics lit his SLX 556 can on fire. So, just food for thought on how hot these Surge high flow cans do get as an Inconel can, 3D printed can. It's all super cool, super interesting.
Hottest spot on the can, 291 degrees. This has been a minute and it's lost 40 degrees delta, but it's 100 degrees hotter. Like legitimately, 30 rounds through this not full auto is 100 degrees hotter than the LVAW on a shorter barrel titanium can though. Titanium cools faster and doesn't get as hot as fast. Still too hot to touch, but there's no deflection of the can barrel interface on the adapter. How hot is the adapter? Okay, so the locking mechanism is 79 degrees. So I could respectfully how hot is the can? 108. So I could probably, I'll try, hopefully.
So I'm surprised I was able to the can so easily down there, because the heat conduction's not coming back towards the adapter as quickly as I thought.
After
so that's
a
cool.
mag dump, I had to run these all in the plus gas setting because we're running subs through cans. There's not enough back pressure to run the bolt, and so that's why the Rattler had a failure to feed.
Lots of gas at the shooter. Unbelievable amount of gas. Unbelievable amount of gas in front of the shooter, but it's not blowing down range. Failure to feeds because of carbon buildup.
215 degrees after second mag dump.
Rattler shooting slow fire, 5 or 6 rounds. The wind's picked up. You can still see how much gas is at the shooter, but it's still significantly quiet. 11 rounds.
That was 11 rounds after ambient, 165. All right, so I drew 2 diagrams here. One is of the SRD 762QD, and this would essentially be a diagram of the SLX SLH. In the video, obviously, we're testing the SLH 300 blackout cans on a 9-inch versus the older SRD can. So one thing you'll see in the video is the SRD cans have a lot of gas at the shooter. Cue the gas, like an exponential amount of gas. One thing about someone who's moving and shooting is if there's gas at the shooter and you are moving off X, when I say X, not this X, but off X where you're standing, that gas is where you were left behind, essentially. So if you're shooting at a target, you can sidestep to get away from the gas. The reason why I drew this diagram is to talk about photonic barriers. You know, everyone's into night vision, low light, no light, illuminators, lasers. And gas at the shooter is obviously shitty, but if you can sidestep out of the way while you're shooting or relocate and shoot from a different position, the gas is mainly around where you were. So you're not putting a photonic barrier downrange with the original SRD cans. With the SLH, SLX cans, especially the SLXs being a higher flow can, they're pushing more gas out forward away from the shooter. And unfortunately, because of that, in the video, cue the gas.
Holy shit, you kidding me?
You're gonna see gas downrange, 10 to 15 yards in front of myself shooting. And when I was actually shooting, I had to slow down my cadence because I was waiting for the plume of gas downrange to disperse. So we shot during the day. Now, if you're shooting at night, you're now creating a photonic barrier downrange. And if you sidestep off X from where you're shooting at some, at the same target, you're engaging the same target, that plume is quite large. And this is the symbol for some angle. You have to get out, you have to move laterally some distance to get to the correct angle so you can actually avoid this photonic barrier. Obviously, we didn't measure how far we have to get out of the way. This is another test we could do at night and actually measure how far off X I have to get to avoid the photonic barrier so my laser, illuminator, or flashlight can PID the target correct.
Here's the SLH suppressor at night, and the can is help forcing gas downrange, but you can see there is a photonic barrier that is being emphasized by the white light downrange. Here is the SRD titanium direct thread suppressor on the tac ops, and I'm able to simply sidestep left and right a foot or two to avoid the blowback and the gas at the shooter, and I can avoid the photonic barrier that the gas is creating. Keep in mind, when this video is shot, there is a backwind that is flowing to the 11 o'clock position on myself, the shooter, blowing the gases downrange and to the left away from me. These gases would be more emphasized at the shooter, and a more strong photonic barrier with the SLH can if there was less wind.
Again, you're getting gases, toxic gases away from the shooter, but now if you are moving towards your target, you're putting those gases in front of you, you have to break through those gases while you're shooting as well. Again, this is super high level analysis of gas location versus gas down range for the two suppressor systems. So I mean, if you're at the range and you're shooting static and you're shooting only during the day, you have no intentions of shooting at night, and you stand behind a bench and run your mags through your gun and it makes you happy, SLH cans will be good for you. You're gonna run Air Pro and you're putting gas down range, but it's during the day, you have the time to wait for it to clear. If you're a really, really dedicated shooter that does perform at night, that does moving and shooting, that does run night vision, low light, no light, really want your gun super duper quiet, run the SRD. And if you're worried about toxic gases, get a soda. Wear a respirator and run your gun even better. So that's kind of the comparison. You're getting, yes, this does get gases away from you, less gases at the shooter, but you're getting something really quiet and a little bit more mission specific, so to speak, than the SLH cans.
This is the SIG Sauer Rattler over the MCX Vertus 9-inch with the SLHC compact suppressor. So comparing the ejection port density of the gas here, a little hard. The Rattler on top is a little bit of a backwind where there's more of a faced wind on the upper and lower. Kind of hard to, there we go. Third shot, you can see a higher density of gas coming out of the Rattler ejection port and out the muzzle compared to the 9-inch. Much more gas. Gun just cycled. The gas, you can see through it. It's, I don't want to say clear, but it has a much less actual vapor density than that compared to the ejection port of the Rattler. And this is the SLH compact can. So it's letting a lot more gases escape out the muzzle. Since it's higher flow, shorter can, less volume, you are getting much more effective forward flow. But not a lot of sound suppression whatsoever. This is the Rattler MCX 5.5-inch, the SRD QD 762. You can see there is a more significant vapor density out of the ejection port. It lingers longer with the bolt closed. More of like a poof that comes out of it. Whereas on the 9-inch, it's more of like less dense vapor. This is the MCX full auto running. The can is pushing gases out the front. It's not pushing them out with as much force as the SLH can, and there is a plume of dense smoke and vapor coming out of the ejection port, lingering. Not much of a wind here whatsoever, and you can see the smoke lingering in my face. It's quite dense, a lot of blowback back into the gas system, and that's on the that's on the plus gas setting. These guns need a plus gas setting to function because we are running subsonics, so there's not enough gas to create a normalized system within the firearm. So you need to increase the flow of the system to cycle for subs, and if we were running supers, we would run the minus gas setting. Now you can see there's a vacuum forming at the bottom of the mag as I blow. Gas is literally being pulled out the bottom of the magazine. That's how much gas and blowback is in the system. This is a 9-inch Virtus with the full-size SLH can. There is gas coming out the ejection port, but again, it's not as dense as the other MCXs that we are exhibiting here. There's a little bit of gas pluming out the bottom of the magazine and the ejection port. And you can see there's a lot more force and energy pressure pushing the gas out the muzzle of the gun and forcing it forward and downrange. Whereas if you compare that to the other MCX, it was more like it kind of, way to describe it is it like looks like cotton balls are coming out. It's just kind of like foof, foof. Whereas this 9-inch Virtus is really hammering it home with the pressures coming out the muzzle. Fire has stopped here. There is a plume of smoke coming out of the ejection port here, but you can tell it's significantly less dense than the previous LVAW style clone machine gun. Even blowing here, blowing the ejection port, a little bit of smoke is kind of creating a smoke ring effect out the bottom of the magazine on the little hole to observe the magazine spring, but not a lot. It wasn't like a thick, dense plume, just simply a little oof, little fart. Back to the LVAW machine gun for some more slow-mo B-roll. Again, this thing is just pumping gas out of everywhere. It's coming so far, it's coming so dense out the ejection port that you're starting to lose track of where my face is. My face is now hiding behind this plume of gas, which was not something we observed with the 9-inch Virtus. We're on to the Rattler here. I believe this is an 11-shot mag dump. We now have a backwind at this point with the Rattler, so we're not showcasing the density of the gas at the shooter as much as we were able to with the MCX machine gun. But again, you can see how dense this gas is between the camera lens and the ejection port, creating a fog around the gun. Olive drab rattle can Virtus. This is a Virtus Tac Ops. Same suppressor as the other one, same barrel length, just a little bit slightly different receiver and handguard setup. Non-machine gun. Again, this is a slow fire video, and not a ton of gas coming out, but we do have that backwind, so it's not fully isolating the gas levels that we had, but still shows that it's not punching a lot of that gas away from the muzzle as far as the SLH 9-inch Virtus. All right, so we have the SLH 7.62. This is a 7.62 NATO. It's Inconel bodied. Its diameter is 1.67 inches. Overall length, 7.4 inches. And it weighs 1.23 pounds with the clutch quick disconnect. All right, so this is the SRD 7.62 QD. It's got a diameter of 1.625 inches. And its overall length, 7 inches. It weighs a total of 1.0625 pounds. So, in review, pretty much have 0.625 pound increase. I'm just doing on the fly math, but a little over 6 ounces increase in weight. And you've got half-inch longer in overall length of the can. So in one half, it doesn't even look like a half inch because measuring them bottom to bottom, it looks more like a 1/4 inch. It doesn't look like it exactly matches how it's advertised. Back of the can to back of the can, we're looking at a 1/4 inch change in overall length. The spec sheets say 7.49 versus 7 inches specifically, or 178 millimeters for the SRD and 190 millimeters for the SLH can. This is 6 ounces heavier. 6 ounces is a lot. That's a significant change in weight. You can feel it too. When you pick these cans up, you can feel it. Now, what is weight on the end of a muzzle? The more weight cantilevered farther away from the firearm will help with muzzle rise. We unfortunately don't have a ton of muzzle rise in these platforms. If you were to free recoil shoot these off shoulder, most of the inertia goes straight back.
This gun, if I hung it from 2 strings and just let it float, right? And yours is the same, and just pull the trigger, it moves straight back. Now with my muzzle brake, it actually pushes the gun down, right? The muzzle brake is pushing the muzzle downward because the gas is coming out the top. With no muzzle brake at all, man, it moves straight back. Come up, right, man? I just want you to put your hand right there, all right? Now, where'd the muzzle go? Up, right? We create that pivot point when we put this in our shoulder.
Muzzle rise on a AR style platform firearm actually comes from the act of putting it against your shoulder, and then when the gun fires, that's where that moment, so in engineering terms, the moment is where the action happens. So you might think, okay, the action's happening at the muzzle. That's the force. Where is the moment? Where is it anchored? So think of a metal beam sticking out of a concrete wall. Well, if you were to put a force on the end of the beam, it's going to bend. Where is it held? At the wall. Where are you measuring your forces? At the wall. So when you do shoulder a firearm and that gun reciprocates backwards, the bolt reciprocates backwards and hits its limit, all that energy is coming straight back, but it's hitting your shoulder pocket. Your shoulder pocket isn't vertical, it's actually slanted out forward. So you're going to get some muzzle rise. Having weight on the end of your gun will make that muzzle climb less. And that's just because you are creating a moment on a slanted surface like your chest, and it's, you know, only contacting the bottom foot of your buttstock, and it's gonna have the tendency to roll upward. Anyway, so for those who might not give a shit about what I'm talking about, a little extra weight is not a bad thing in terms of recoil management, but this is a very heavy can. Now we're talking about the SRD 762QD. This can is significantly quieter, and it's significantly lighter. 6 ounces of lessened weight is huge. Ounces are pounds at the end of the day. You know, you guys might hear a lot of people throw that around. You might not have ever experienced it. I was elk hunting in Idaho on our first day. We did 10 miles on foot with 30-pound packs. I had an 11-pound rifle, and that's loaded with a scope. And ounces really made pounds. I asked the guide, I was like, he wasn't carrying a rifle. I was like, can you carry this rifle for like 5 minutes? And just passing off an 11-pound rifle, which doesn't seem like a lot, I literally felt like I had wings. I was like, second wind, all right, I can make it another mile. So ounces are pounds. Ounces are pounds. And this is ridiculous. So Inconel is a very dense metal, and this is a 3D printed Inconel can. So you are going to have, because it's 3D printed, you're going to have thicker wall thicknesses, thicker baffle thicknesses, and that's why it holds heat, traps that heat, weighs so much. And Inconel is a heavy metal compared to steel. So there's the metallurgy behind it. The clutch lock at the back of the suppressor is also quite hefty. You can see there's a to it. There's the and then internal surface with the and the. It's pretty heavy duty. The SRD QD has this little nozzle effect well chamber, and then this very basic, looks like, I think it's like three large that is on, and then the tapered face in there. It's a short tapered face, and that's it. So you have a beefier, more robust suppressor, but it's heavy and not as quiet. So this one puts more gas in your face, that one doesn't. So that's the side-by-side comparison of these cans. You know, and then we can talk about length. You have a 9-inch gun. So this suppressor, this is the new SLH Compact, or SLHC. This is 5.24 inches long and weighs 0.96 pounds or 15.4 ounces. This little guy, this little 5-inch can, weighs 6 ounces lighter than this full-sized SRD QD. So you're now, there you go. The dwell chamber and the nozzling effect on this can is all in here, and the actual latch system is here in the bottom. This latch system is all this long-bodied section of the can. So you're getting, I don't know how much would actually, there. So there's a taper. So right about where the collar starts, up over where like the locking markings are on this, wherever the locking markings start is where the taper ends and the dwell chamber begin. And the actual first baffle, the flange of the first baffle starts about there. On this can, taper stops right where you see the radius on the side of the can, and then the dwell chamber and the first baffle go to about here up the side of the can. So this can starts sooner. The dwell chamber on this can begins sooner and shorter and closer to the muzzle device of the firearm, right? Starts much closer to the muzzle device, and you have more surface area and more baffles over distance than the compact can. They weigh the same. So this is a high flow can. This can is not quiet. This can's exact purpose in this 9-inch setup be to suppress muzzle flash, suppress rapport at the muzzle, help break apart that muzzle flash of unburnt powder, and you're not adding a ton of overall length to the firearm. So this is 5.24 inches, and this firearm at the muzzle crown is 9-inch barrel length, and then the actual barrel crown is somewhere down here where my pinky is. You have another inch of length on the gun that goes into the can. So let's call it 5.25 inches of length added to this gun. Quick math, 14.25. So the overall length of this from the barrel length with the can, 5.25 inches. 14.25 inches. That's not bad. That keeps a 9-inch gun fairly compact, fairly workable. I've got lots of workspace up front. I've got my light, my laser, my switches, and my hand stop. It's comfortable. It's a nice length of pull. Got my EOTech here, and it gets the job done. I'm happy. It's doing. If I want a capable 9-inch platform, so the 9-inch MCX is going to be better ballistics, better terminal ballistics than the 6.75 or the 5.5 Rattler. So you're getting better ballistics out of this gun, and you want something when you're running subs to be obviously a less jaw rattling. This can's for you. You want a short little can, a good truck gun. This is a great little setup. You can see how much more length the SLH full-size can adds. This one does offer sound suppression, but at what cost? And you're looking at 21.1 ounces versus 15.4 ounces. That's a lot. That's pretty much almost the same weight differential, almost the same weight differential between these two. Anyway, Inconel can, it's interesting. Inconel baffles that are welded together like this versus this very unique geometry Inconel can. Thinner wall thicknesses all around. This doesn't get as hot as quick. This holds heat just as long technically, but this has a much larger thermal mass, heavier, more dense. This has more internal volume. This has more internal voids, right? Larger, more volume, more open air volume in the can. This has a lot more chambers, smaller pocketed chambers. We can refer to the patent information, central core, It's like an external cord sleeve that's 3D printed, but there's more metal inside. And in engineering, we call them fins. Anytime like a heat sink, if you ever see a heat sink on a computer, those are fins. It's so that the fins get hot quick, but they wick away heat faster because of the fan blowing up. That's how it's drawing heat from the system, cool faster that way. The cross section of one of these cans mimics a heat sink much in the cross section of one of these cans. This is such a hard video to do. It's like at the end of this video, people are gonna say, well, what would you choose? And the answer is, I don't know. I want something super quiet that doesn't create a really quick heat signature that fits on Rattler, that functions well on the Rattler, it functions on the 675 guns. You want a QD, this is the can for you. This produces more gases in the operator's face and close to the operator. If you want something that's not as quiet but moves more gas away from the operator, has a much more sound muzzle device attachment system, quick disconnect system, this is the can for you. If you don't care about a ton of sound suppression and you're most worried about just lowering the rapport at the shooter, for the shooter, in tight confined areas, and you want that muzzle flash to be soaked up, SLHC. This does almost nothing for sound suppression.
All right, so in closing, you learned a lot about these suppressors, and we know that the SLH cans, not as quiet as the SRDs, do serve a purpose. And that purpose is getting gases away from the shooter. The sound quality of the SLH full-size can, 30 cal can, is decent. The suppression. Now SIG does make the 556 series SLH, 556 series SLX, SLX compact, and they also have a titanium line of 300 blackout cans. Now, I did hear that the 300 blackout direct thread full-size can from SIG is actually very comparable to the sound decibel reduction and the sound quality of the SRD 762 QD. So that's good to know. I have one on order, so we can do a follow-up video at some point of that. Really like the clutch lock. This is an amazing adapter. The muzzle devices that they are providing are really great too. They come with 90-degree shoulder and tapered shouldered muzzle devices. So if you wanted to equip a AR-15 with a 90-degree shoulder, that exists. I know for a military unit, SIG did take the SRD series cans and create a clutch lock version. And that would be nice to see in the future if they did actually do a baffle style clutch lock. Now, SIG's business is driven by contracts, so we can honestly assume that the SLH series, that style of surge can with the high flow away from the operator, that's more for government and military purposes about, you know, air quality for the shooter. And these are people that shoot all day long professionally. So, you know, you sacrifice some sound suppression and quietness and discretion for something that actually provides a higher quality of life. So that's cool too. So those are the two perspectives on them. Most of us civilians just want something stupid, quiet, because we're not shooting a ton, or we're hunting pigs, or, you know, hunting wild game, and you're allowed to shoot cans at night. You want it quiet, subsonic. These are the better cans. Now these are discontinued by SIG. You can no longer buy these new direct from SIG. They do say that they will be servicing these cans for the life of the cans, but a lot of the support is gone. It's hard to find the muzzle devices. Some of the old muzzle devices for the 556, the little one-port compensator, those would actually get so hot in a machine gun that the front face would flex away and eventually blow through the can. So if you have one of those, I would say switch over to a 3-prong if you can. Those do deform in time. I mean, that's if you're running a ton of rounds through it. So something to consider. You can still get these. I think you can get them on Gunbroker. There's some shops that are offloading a ton of these. They were cheap for a while when they came out. When SIG announced the discontinuation of these, they were on pretty discount for dealers. But now a lot of people are trying to scoop these up before they can't get them anymore. If I have an alternative for this can, is that probably I would suggest like a Nomad 30 from Dead Air for direct thread, and maybe the Sandman L for QD. Those would be the next competitor to this.
this baffle style can. So if you're looking to replace your 300 blackout with baffle style can, you can try the Sandman or the Nomad series. These cans are great. They're super hard use, super heavy duty. They're a little heavier, which is kind of nice. It keeps that muzzle down, and they're higher flow. You obviously have the negatives with them. You get vapor and gas downrange that create photonic barriers. But if you're a daytime shooter on a shooting line and that's all you have access to and that's all you plan on shooting, this is a great can for you, right? Daytime, you can see through the gas mostly. Supers as well, you're gonna have less gas shooting supers. So this is a more robust can. If you can find the SRDs, I would say still grab one. If you don't have one and you have a dealer that has one and you wanna grab one now. They're great cans. I really, really like them. They're really quiet too. And you're just never gonna get something like SIG that's that quiet again in that platform. In this video, we only tested subsonic ammunition. Subsonic ammunition does produce more gas when fired. Supersonic ammo is gonna burn hotter, and it really showcases how well these cans work with subs, right? So you're gonna get more gas testing subs, and we picked probably the worst day or best day for video to showcase water vapor. It was one of those mornings that was like kind of cool after a warm front, so you had a lot of visible vapor coming out of your mouth, and it really emphasized the gassiness of the certain cans on the certain models. So we got lucky when we filmed this. All right, so these cans are a little pricier. SIG Parts online was selling this specific model for $1079. Saw another one, the TI version, for $996. So you're sitting around $1,000 for one of these cans. Now it's pretty cool. It's 3D printed. You get baffle profiles that don't exist in reality, that are not machinable. So it's a really cool can. You get the clutch lock system, and it comes with some muzzle adapters, but then you can get the quick disconnect parts from SIG's website. So that is cool. I don't know how much these are going on the market. I would expect they're going up in price. I see a lot of people driving them. And then the dead air cans are sitting around like the $900 mark. So they're competitively priced. I think they're a robust system. I think it's what people want right now. And it's what the government wants. It's what all these military contracts want. They want something that's less gassy at the shooter. And SIG delivered. If that's what their primary focus is removing gas from the system and driving it forward, they succeeded. Better civilian can for lower round count shooting, hunting. Better can for super hard use, beating the crap out of your gun. And removing your suppressor on and off is also much easier with the new clutch lock system. So thank you so much for watching. I hope this answers some of your questions. Again, it's going to come down to personal preference, whether you want the capabilities of the SLH series or the capabilities of an SRD if you still have one or you're trying to acquire one. And then, of course, you can replace your SRD requirement with the Dead Air Nomad or Dead Air Sandman L. And there's plenty of other cans out there that would also do a decent job. So thank you for watching. Hope you enjoyed all the scientific side of the conversations here and the analytical breakdown of these suppressors from more of a end user point of view rather than like a scientific point of view. So hope you enjoyed. Thank you so much.